Here, let us see about the different steel and cast iron. That is the iron carbon alloys, different types of iron carbon alloys. Okay. So metal alloys, they are classified into two types. One is ferrous and another one is non-ferrous. Ferrous means the alloys of carbon and iron. Okay. In ferrous, you are having steel and cast iron. In cast iron, there are different types. One is grey iron, another one is ductile iron, another one is white iron, malleable iron, and compacted graphite iron. In steel, you have low alloy steel and high alloy steel. Low alloy steel is low carbon, medium carbon, and high carbon, depending on the percentage of carbon. So low carbon is again plain and high strength and low alloy. Medium carbon is plain carbon, it can be heat treated. High carbon is plain and it becomes steel. 2. High alloy, that is steel of high alloy, becomes the stainless steel. So these are the different types of iron carbon alloys depending on the percentage of carbon added to iron. So here you can see that when the ferrous alloys you are having steel which is 1.4 weight percentage of carbon and cast iron is 3 to 4.5 weight percentage of carbon and non-ferrous is copper, aluminium and all this. Okay, and other alloys which don't include iron. Here you can see in this diagram which we already saw, the iron carbon diagram. Here you can see the austenite state which states the percentage of carbon from 1.4, that is less than 1 to 0 to 1.4. Here it is called as the steel, and when the composition changes from 3 to 4.5 then it is called as the cast iron. So depending on the phase diagram or depending on their phases and their compositions, they have different names and different properties. Apart from the above, we have the other terms to determine the carbon steel. They are plain steel, mild steel and low carbon steel. They are available in almost all product forms, that is sheets, strips, bar, then plate, tube, pipe, etc. That is, they can be made into any shape. Their designation, this number is given, this number indicates the number steel, the weight percentage and the temperature. Okay, so 0.40 weight percentage of carbon up to 2 weight percentage. It is called as the carbon steel. The limitations for other alloying elements, silicon you can use, copper you can use, Mn, manganese you can use. But there is a limitation for adding their weight percentage. It should be up to 0.6 and our manganese can be added to a maximum of 1.65. So there is a limit for adding other alloying elements to make the alloys. So here you can see the designation and applications. So this is the number, different numbers which are given that indicates their grades. So this is the mixture, okay, copper, chromium, nickel, molybdenum and all this and their applications. AISI is the standard of American Iron and Steel Institute which denotes the various percentages, various compositions. M1 indicates that all these elements are present in this composition. Okay. A2 represents that they are present in another particular composition and the typical applications. The applications are different dyes, punches, and embossing dyes, etc. Okay. O1 means they are used for shear plates, cutting tools. Then S1 they are used for pipe cutters, concrete drills. W1 they are used for blacksmith tools and woodworking tools. Okay. So depending on their hardness, depending on the percentage of various materials, they are classified and their applications differ. You can find out that there will be only minute percentage change but the property will change enormously. Their hardness improves, or they can be made into sheet, or they can be made into tubes, or something like that. So depending on the composition, the property also varies a lot. So here you can see that the carbon steel. So how they are manufactured? They are manufactured using cold finished, hard finished, or bars. They are used to prepare bars, plates, strip. That is, they exist in bars, that is plate, sheets, and strips. Okay. Their composition is Fe plus C plus Mn. You can add the options also. Right. The microstructure, it is hard, martensite soft, and ferrite plus pearlite. They will remain in ferrite and pearlite structures. Okay. Alloy steel, they are hard finished. They exist in bars, arc, and some in plate shapes. Here also you can find out that you are adding Fe plus C plus Mn, but the options, they are alloying composition, all these elements, chromium, nickel, and all these can be added in various percentages. Okay. So here the tools, steel, okay, they are hard finished bars. They are special. They have special properties or quality assurance. Okay. So they are hard and martensitic, and they are alloy carpets. The soft means they have the ferrite and carbides, pearlite in the work. Okay. So here you can see the microstructure itself varies. The microstructure shows different compositions. Okay. Here the microstructure is, for the first one, the microstructure is different, and this is entirely different from the microstructure of steel. Okay. So this is how the alloying percentage changes or varies the properties of the material. So here you can see how the hardness is. With the temperature, the hardness decreases. Initially it is more and it decreases. See how the curve varies. Okay. So here the decrease is like this, but here you can see it gradually decreases. But in the case of steel, which is used as tool steel, then here the hardness is in curve entirely different. Okay. Then abrasion resistant is the wear volume with the time. Okay. How much stress they can withstand. Okay. Wear and tear, you may be calling it a wear and tear. So how much stress they can withstand. So here it shows that different carbons will have different wear volumes. So the wear volumes changes, okay, with respect to time, and this also determines the property of the material. So we have seen about the types of alloy of iron. So this is one of the types of casting, which is called as gray iron, where you can add silica from 1 to 3 percentage and carbon from 2.5 to 4 percentage. The graphite plates that ferrite are pearlite prisms because of the platelet graphite. They will be weak and brittle under tension. Okay? But they will have a strong under compression. So tension and compression you can do. So tension, its property changes, and under compression they become stronger. They have excellent vibrational dampening. They can be used as wear resistant materials. Then ductile iron, that is a very small percentage of Mg or Ce is added, then it becomes ductile iron. They are matrix often pearlite or ferrite. Their ductility is increased by 20 plus 20 is double. Okay. So when you are changing the concentration of the tokens or the compositions of the materials which are added, then their properties also changes. The next about the casting, which is one is white iron and another one is magnesium iron. Okay, white iron is less than 1% of the side, harder surface iron. Okay, The large number of people receive after during casting. Okay, they form the iron carbide. Variable iron is the result of annealing white iron to 800 to 900 degrees. When you are annealing this white iron or heating, annealing is the heat treatment. When you are heating, then it becomes at 800 to 900 degrees, it becomes malleable iron. It is in the form of cementate alloy. The graphite precipitates either in the form of clusters or roasted. They are more ductile. So you can find that white iron can be converted into malleable iron by changing the temperature. This is next cast iron, which is compacted graphite iron. Okay. The carbon content is 3.1 to 4% and SI is from 1.7 to 3%. So there is lower content of Mg or C. Lower percentage of Mg or C is also added. They have the warmness of graphite particles. Here in the image you can see the graphite particles out here. They have high thermal conductivity, better resistance to thermal shock, and they have lower oxidation at elevated temperature. So this is another type of cast iron by changing the composition of carbon and zinc. The production of cast iron can be produced by adding the carbon content and other dopants along with the iron and heating them. Okay. So here you can see it is pearlite is formed, which is malleable. Here the content is slow cooling, the content is ferrite and malleable. Okay. So you are holding at the temperature of 500 degrees for 30 plus hours. So fast cooling gives you another type of material and slow cooling gives you another type of material, even though the combination is the same. Okay. So here also you can see white cast iron, pearlite grey cast iron, then ferrite grey cast iron, pearlite ductile cast iron, okay, and ferrite ductile cast iron are produced by mixing glass with iron within a very small depth range. Okay. So by changing the composition of carbon and by changing the temperature, you will be getting different types of carbon. You can have the metal fabrication methods. There are three things: one is forming, another one is casting, and another one is joining. Okay. Forming means it can be forged, hammer or stamped and rolled. Okay. So by making a die, you can make it into force. By force you can send and then you can get it. Okay. By rolling means the thin sheets are made and rolled into necessary shape, needed shapes. Okay. And another one is by drawing. Okay. This is also a type of rolling, but this is different. Okay. So you can get the rods, wires and cables. The die must be well lubricated and they should be clean. Okay. With the tensile force you will be getting it. Okay. So here extrusion by rods and by tubing. So you will be having the rods which will be through which the melt will be sent and you can get it. Okay. So it is called as extrusion. You can see here they are made into the rod shape by through a die when they are passing. The die can pass different types. So ductile materials, copper, aluminum, hard. Okay. So they are melted and they are passed through different shapes and they are burned. So forming methods is forging, rolling or drawing or extrusion method. This is one of the fabrication method which we are using. This is another type of fabrication method which is called as casting. Casting is mold is filled with the metal. Right? So you will be having a mold and here you can see that sand is filled and you will be pouring the molten metal and putting inside and you will be getting the product. Okay, in the desired shape. So metal is melted in the furnace and the cheapest method, which is the cheapest method, they use production of shapes, different shapes. Okay. There may be internal defects found because of the molding. So they are good options for prepared materials. Next is the sand casting, that is large parts example auto engine blocks. Okay. So we cannot hold something too hot only, sand can withstand. That is its melting temperature will be more than 1600 degrees. Okay. For sand. So you can put sand after using the shape, fill it, and you can pour it. You can see this on the ways people are doing. Okay. On the way people are preparing the molds of different shapes. They will be using the sand casting method. In the investment casting, you can have the pattern which is made from paraffin, that is wax, and we will be creating a mold in plaster of Paris and melt the wax and all of the mold left will be left. Okay, so you can get the ring. So pouring method, and you will be getting low volume complex shapes, that is jewelry, turbine plates, etc. So mold will be made up of paraffin in plaster of Paris mold. Then you will be making the pattern inside, like what the statues are made. You can see that how the statues are made. There will be mold and they will be pouring the melt into it, and the melt will be taken out and the wax will be removed. And in die casting, it is a high volume and low T alloys are used. Continuous casting, you will be getting simple slab shapes. So all these are the methods of preparation of the various types of steel. So this is the third method is joining. Joining means welding or melting and joining together. Okay, so powder metallurgy, the powder will be under heat, it will be melted and compressed. So you will be getting the melt which is joined together. Various materials will be melted and compressed, that is called as joining. And welding is when one large part cannot be done, you have to join two parts. So one part will be melted and it will be joined with another part, and that is called as welding. That is also a method of metal fabrication method. So forming, we have already seen forming method, casting and joining method. So these three are the methods by which we can make metals.